Hi folks, we're getting towards the end of the series of videos on trig functions for students studying A-level maths who are in year 12. In this lesson we're going to look at solving trig equations. I think we'll probably need another one after this to look at some more complex trig equations, but let's not waffle, let's get straight on with it. Example 24, find the solutions to sine theta equals 0.5 in the interval 0 to 360 degrees. So that interval at the end of the question is really important. If it wasn't there, there would be an infinite number of solutions to this question. So by limiting that little window of the sine graph, we're just going to get a few solutions back. Okay, so I'm sure you will remember from the exact values video that if we've got sine theta equals 0.5, well, to get theta, we would find arc sine of 0.5. So if you like, sine to the minus 1 of 0.5. And if you can't remember the exact values video, then you could just stick that in your calculator as well, and that would give you an answer. It would give you an answer that theta is 30 degrees. Now, it's worth bearing in mind that the first result that the calculator gives you is known as the principal value. And from there, we need to do a bit of work to work out all the other possible values. So once we've done this, we can either use the unit circle, or we could use a trig graph to work out all of the rest of the answers. Let's start by doing the unit circle. Okay, so all students take care. There's our unit circle there. Quick sketch, and theta was 30 degrees, so our first solution came up here at 30 degrees. And obviously that makes an angle of 30 degrees with the horizontal. And it was a positive value, so sine was positive. So we're looking, where else might sine be positive? In this zone, which goes from 0, 90, 180, 270, and all the way back round to 360 degrees. So yeah, so hopefully you realise that it's going to be quadrant 2 that we're interested in. So we make a line down there, and we're always interested in the angle that's made with the x-axis. So we're going to work out this 180 and then backtrack 30 degrees would take us to 150 degrees, and there we've got it. There's our other value for this formula, for this problem. So we would say theta equals 30 degrees and 150 degrees. Okay, the alternative method would be for us to sketch out a sine graph, something like this, and you'd be able to do this just from your skills from lesson 1, wouldn't you? Something like that. And then think about where a half would be. So okay, we're going to get down here, and that first result was 30 degrees. This is 180 degrees, and so this gap here is the same as the gap over here. So that's going to be 180 minus 30 is 150 degrees. So that's another way of finding all of the other solutions. And you can see if you continue that line on, we wouldn't cross the sine curve anymore. So we're happy that we've got theta equals 30 degrees and 150 degrees. That's our answer for that question. Alright, let's have a chat about these principal values that I mentioned earlier. If you've got a standard calculator and you type in sine to the minus 1 of 0.5, assuming your calculator is in degrees mode, you'll get an answer back of 30 degrees. So that's the principal value that you could then use to go on and solve a trig equation in a given interval. We know that the sine graph repeats itself every 360 degrees. So really, if we were trying to solve sine x equals 0.5, there would be an infinite number of solutions. And obviously the calculator can't return an infinite number of answers. So the answers that a calculator gives back are limited to a certain interval. These intervals are, for sine to the minus 1, or arc sine, you'll get answers back for theta between minus 90 degrees and 90 degrees. For arc cos, you'll get answers back between 0 and 180 degrees. And for arc tan, it's between minus 90 degrees and 90 degrees. And the reason for that is because it creates a one-to-one mapping in that little region, that little interval. You'll come on to look at mappings when you study functions in year 13. Example 25. Find the solutions to 5 sine theta equals minus 2 in the interval at theta is between 0 and 360 degrees. Right, so we've got 5 sine theta equals minus 2. If we just divide through by 5, we'll get sine theta is negative 2/5. And from there, if we did the inverse of sine arc sine, we get theta equals sine to the minus 1 of minus 2/5, which you can put into your calculator, and it will return the value minus 23.6 degrees. I've rounded that to 1 decimal place, 3 significant figures. So there's our principal value. And straight away we can see that our principal value is not in the given interval. So we'll have to do some work there just to get that first value sorted out. So let's think about the unit circle. All students take care. There we go. There's our circle. And where's minus 23.6? It's down here, isn't it? Because we always measure anti-clockwise is positive, clockwise is negative. So down here, this would be minus 23.6 degrees, making an angle of 23.6 degrees with the x-axis. We're always interested in the angle made with the x-axis. And that makes sense because if you look, all students take care, down here in quadrant 4, only the cos function is positive, so the sine function would be negative. And we're looking for the other quadrant where sine is negative. Hopefully you can spot that. It'll be down here. Down here, where this angle is 23.6 degrees. So let's just work out what that would be. Working round, we've got 0, 90, 180, add another 23.6, gets us to 203.6 degrees. And if we track down round 360 and then come back 23.6 degrees, another value for here would be 336.4 degrees. Now, we'd be better off rounding off our angle values there to 3 significant figures. So we would get theta equals 204 degrees and 336 degrees to 3 significant figures. So that's how you do it using the unit circle. Another alternative method would be to sketch out the sine graph. Something like this. Be under here, so it's going to look something like this. Come down to here. That's 360. Here we've got 180. That's 90. 270. That would be minus 90 degrees. And if we think about where minus 2/5 would be, minus 2/5, maybe something like this. Come across here like this. Okay, so there's our first answer that the calculator gave us, which was minus 23.6 degrees. Then if we move up a full 360 degrees, we're going to get to this answer here, which is our 336 degrees. And hopefully here you can see some symmetry. You can see that there's a line of symmetry that kind of runs through 270 degrees. So whatever gap this is, we're going to get the same gap here. Same gap there. So we're adding 23.6 to 180 degrees. So this value is going to be, that's going to be our 204 degrees, isn't it? So again, using the graph, you could get to the same conclusion, that theta equals 204 degrees or 336 degrees when you round to 3 significant figures. Alright, let's move on. Example 26. Find the solutions to cos theta equals root 3 over 2 in the interval 0 to 360 degrees. A student writes the following working, and then there's a bit of working out. And identify the error made by the student and find the correct answer. So you could get asked one of these kinds of questions in your exam, and probably the best way to handle these is just to forget what the student's done for now and think about what you would do in this situation. So just try and solve it as if you've got a blank piece of paper in front of you. So let's start. We've got cos theta is root 3 over 2. So theta will be arc cos root 3 over 2. Hopefully you can remember that. But if not, you can put it into your calculator. You should get theta is 30 degrees. That's our principal value. So then, thinking about the unit circle, I'm going to use the unit circle from now on. That's how I usually solve them. I don't normally draw the trig graphs. Our 30-degree angle would get us to 30 degrees. We've got to think where else is cos positive. Well, it's down in quadrant 4, down here, making an angle of 30 degrees with the x-axis. So this one's going to be 330 degrees. So without looking at what the student's done, I think this should be 30 degrees and it should be 330 degrees. Right, well straight away then I can see what the mistake the student's done, because they've written down that it's 30 degrees, which is right, or 180 minus 30, which is 150, and that's the wrong bit, this bit here. This is the bit that's incorrect. So we've got to say, what have they done wrong? The student failed to correctly identify the quadrant where cos is positive. The correct answer is theta equals 30 degrees or 330 degrees. All right. Example 27, last one. Find the solutions to sine theta equals root 3 cos theta in the interval 0 to 360 degrees. Right. Start by writing the question out. Sine theta equals root 3 cos theta. So in this question, maybe we could apply one of our trig identities. We can't see an obvious way of solving this any other way. We've got sine and cos there, so maybe if we can get that together as one thing, one type of trig ratio, that would be really helpful. If I divide through by cos theta, I'll get sine theta over cos theta equals root 3. Okay, hopefully you're shouting at the screen now saying sine theta over cos theta is tan theta. So you get tan theta equals root 3. And if you can remember your exact values, arctan of root 3 is 60 degrees, isn't it? Okay, so now we just need to know if there are any more solutions in that interval between 0 and 360 degrees. And hopefully you've absolutely mastered the unit circle now and you know exactly what you're doing. But let's put in our first solution. So if that's 60 degrees there, this takes us to 60. That's where tan's positive. And where else is tan positive? Tan positive is tan is also positive down here, if that's 60 degrees. So that would be 0, 90, 180 plus another 60 degrees takes us to 240 degrees. So there's our other solution. So hopefully this is all making sense. You might well have to use a different trig identity, maybe like sine squared plus cos squared equals 1 in some of the examples I've set you. So there's the exercise to have a look at. And always have a go. Take care. Remember to Take your angles always from the positive x-axis, not the y-axis, and hopefully you shouldn't go too far wrong. Some kind of tough questions towards the end. Question 11 might have you scratching your head for a little bit. Good luck with that, and I'll see you later for the last video in the sequence, which will be video 8, slightly more complex trig equations. Bye for now.